We're given a graph that's showing a relationship between Kenny's distance from home, this is important, I want you to underline that, on a bike ride, and his time. So time is the independent variable, so it's graphed on the x-axis, and distance is the dependent variable. The distance he travels depends on the time that he takes, right? So his graph is broken down into 3 segments. We have segment A, segment B, and segment C. And we need to describe each segment of his ride. Just by looking at it, do you think that he is traveling at the same speed for the whole trip? No. Okay? We're looking at a relationship between distance, and I want you to copy this down as well, distance over time. So distance in kilometers over time, which is in minutes. So think about this. If you're looking at kilometers per minute, that is referring to your, starts with an S? Speed. Okay? So the relationship here is going to show us the speed at which he's traveling. Distance over time. Rise over run. Each segment is a line, a straight line. Each segment is different. We're going to start with segment A. Okay, and I just made it smaller here, but you have it on your paper. We need to figure out from his starting point, okay, he starts at 0, so he is 0 kilometers from home. He has not left his home yet. How long does he travel for? What's the length of time he travels for in the first segment? 10 minutes, good, because he stops here at that speed, and how far has he traveled? Okay, pretty easy to read the graph. So the distance traveled would be 3 kilometers in 10 minutes, okay? And the direction, what they're looking for here is if he's traveling from home, remember I told you to underline that, is his direction away from home or is he going towards home? He's traveling away from home, okay? So I want you to write here, away from home. If his distance is increasing, that means his distance from home is increasing, which means he's traveling away from home, okay? If the line was going downwards, let's say, if I did that, what would you say about the direction for that one? Yep, going towards home. He's going back home, okay? You're going to see questions like that in this chapter. So what would we say about his speed? How fast is he traveling? The speed is 3 kilometers for every 10 minutes, good. To figure out what that is per minute, we take 3 and divide it by 10, right? 3 divided by 10 is equal to 0.3 kilometers for every 1 minute. That's his speed right now. He's traveling 0.3 kilometers in a minute. For section B, what do you notice about the line? What kind of line is it? What kind of line is it? It's a horizontal line, yes, which means it has a slope of 0, okay? If the slope is equal to 0, that means that the rise of this line, does this line rise? Does it have a run? I want you to tell me right now, what is the run? It goes from 10 to, what number would this be? 25. So going from 10 to 25, how many minutes have passed? From 10 minutes to 25 minutes. Yep. 15 minutes. Okay, does everyone see that? The time that has passed in segment B is 15 minutes from 10 to 25. 25 take away 10 is 15. Does everyone understand that part? Has his distance increased or decreased in segment B? Has there been an increase or decrease in his distance? No. So what's the distance traveled? 0 kilometers. So if he has traveled 0 kilometers, but time is still passing, right? What's happening in this point? So his direction, he's not moving. He is stopped. Maybe he took a break. Maybe he saw a friend and he stopped to talk to them for 15 minutes. There could be a number of scenarios that are happening right now. Whenever you see a horizontal line on a time and distance graph, it's always no movement, okay? So I want you to write that down. No movement if the line is horizontal. Time is passing, but there's no change of direction. Okay, 0 kilometers in 15 minutes, which is the same as 0 kilometers per minute. Every minute that passes, he's not moving. Okay, so now we're gonna look at line segment C, and it started at 25 minutes, and where does it end? Where does the line segment end? How many minutes? 50 minutes. So how much time has passed during his travel in segment C? From 25 to 50 is good, 25 minutes. Okay, we have to figure out the distance. So from this point, he was 3 kilometers away from home. And where he ended, he was how many kilometers away from home? The ending point of that segment was at 4.5. He started at the 3 kilometer mark and he ended at the 4.5 kilometer mark. So how much, how far did he travel in this segment? What's the distance that increased? 1.5 kilometers, good. And what is his direction? Is he going back towards home or is he still traveling away from home? Good, he's still traveling away from home. Okay, so he has a speed of 1.5 kilometers for every 25 minutes. And what would that be? How many kilometers per minute? So divide 1.5 divided by 25. 0.06 kilometers. At which segment is he traveling the fastest? Okay, so let's add that here. He's traveling the fastest here. He's traveling the slowest in C, and in B he's not moving, right? If you look at line A, you've already concluded that that's the fastest speed. Which line is the steepest? A or C? A. So the steeper the line, the faster you're going to travel. This is the steepest. Okay, so you can just look at it and automatically know, well, I know he's going the fastest in segment A because his speed is the greatest. You can compare the speeds.